So we've got two functions. F of x is x plus 2, and g of x is the absolute value of x. So first of all, we're going to state the domain of each of those. So for f of x, our domain would be, what kind of graph is that? It's a line. And what do we know about the domain of a line? It's all real numbers, and same thing with the range. It's all real numbers. For g of x, what kind of graph is that? Absolute value graph. The domain also, there is no non-permissible values. The domain is everything. The range is y is bigger than or equal to 0. Now, if h of x is adding those two together, we're going to write an explicit equation. So there's a new definition. An explicit equation is just an equation in terms of x so h of x would equal, well, we take f of x and replace it with x plus 2, and we take g of x and replace it with the absolute value of x, and an equation that just has x's involved is called an explicit equation. Now we're going to determine its domain and range. So if you were adding these together and you had a line and you added to it an absolute value, can you see that its domain would still be everything? What's going to happen to the range, though? Let's just look at the graph here. The x plus 2 would be a line with a y-intercept of 2. There's x plus 2. I'll underline that in blue. Absolute value of x would look like this. What's going to happen when we add these together? Can you see at a certain point here that these negatives and these positives, when they get added together, what's going to happen? Okay, so let's do some points here, and I'll make our new graph in black. 0 plus 2 would be 2. Here we would have 1 plus 1 would be 2. Yeah. So that's what we're going to find out. Does it always stay positive? Okay? Because we're always going to be adding values, but the question is the even when you go into a negative value here, so let's choose a value, let's say when x is equal to minus 1,000. This is going to be positive, this is going to be negative. These two are always going to cancel out, and then this one's going to be left at 2 all the time. Then after that, it's going to, well, it's going to increase faster than that. And so our range is going to be bigger than or equal to 2. And I think you can really see that it's always going to be equal to 2 if you look at the equation here and you say, well, what happens when I put in a negative number? When I put in a negative number, this and this will always cancel out. Because if I put in negative 5, the absolute value would make it positive 5, but over here I would have a negative 5, and they would cancel out. So for any negative number, I'm always going to get 2. And that's the smallest it ever goes, because once it's a positive number, when it's a positive number, the absolute value of x won't make a difference. So it's like you have x plus 2 plus x, and that would be the same as 2x plus 2. So if you graphed my new black line here as a line where the y-intercept is 2 and the slope is 2, it would be a steeper line than what we had to begin with. And that's how we could see the graph. Now for part C, we're doing the product now. We're going to write an explicit equation. H of x is equal to, and it will be x plus 2 times by the absolute value of x. Yes? Oh, it is p of x. That's just a fancy looking p. I haven't finished drawing it yet. There we go. So p of x is x plus 2 times the absolute value of x. Again, for its domain, the range is everything. And the domain is a question that you can always answer by looking at the domains of the functions that you had to begin with. For the range, if we look at our green graph and our original blue graph, and if we think about multiplying them, can you see that you're going to get some places where it's positive? Because where both the green graph and the blue graph are positive, when you multiply them together, they're going to be positive. And where the green graph is positive and the blue graph is negative, when you multiply them together, you're going to get negative values. And since the values get bigger and bigger and bigger, you can get as big a number as you'd like for your positive values. And same thing, you can get as big a number as you would like for your negative values. So our range is going to be everything. Yes? Well, if you wanted to simplify this function, you'd have to write it in 2 different parts. Because the absolute value changes, the graph kind of changes when it's at 0. It's going to be x squared plus 2x only when x is bigger than or equal to 0. And it's going to act like negative x squared minus 2x when x is less than 0. You could write that as well. Okay, questions you can do for this one are 3, 5, and 10.